Seems like we're about to start. Would you introduce yourself, please?
Yes, of course. I'm Pedro. I'm the founder and owner of Bisect, and Bisect is a software engineering house, and we help manufacturers with developing anything from a small library or a turnkey products. We focus on anything related to media, so STG10, NMOS, of course, a lot of GPU stuff, Docker containers, all of that. I'm also a SMT fellow and importantly a member of the AMWA architecture review group, where we help keeping the things rolling in terms of the specifications defined by AMWA.
Wow, that's an impressive track record and a long time C++ fan, I would say.
Yeah, and recently a Rust even more fan. Converted to other technologies. How about you? Do you want to a bit about yourself?
Oh yeah, I've been walking around a little bit in the broadcast industry since 1999. Started off as a support engineer, did a little bit of project management, then some process management, because when you move from tapes to files, then suddenly you realize we're in the IT industry, and then you need to think about ITIL processes like change management, problem management, incidents, and that sort of nice stuff. But to be honest, well, if you're a technologist, then maybe this is not what you'd like to do for the rest of your life. So the moment I saw the opportunity to do another project, moving from SD to HD, I jumped upon it. And I thought, well, after this is probably where everything stops. We've done everything stops, right? And we can continue with our lives. And then I saw an interesting move. I think it was 2015. I was already doing some sort of an architecture role at VRT. And then the move was a little bit getting away from SDI into IP. I thought, this is interesting. And I jumped immediately on this topic. And this is why when I joined EBU for the first time, I should say, got into connection with AMWA, with SMT, all those organizations you probably need to know. And then, well, the story started more or less. I went back to VRT. There was a very good reason for this, family reason, don't need to explain this here. And then I moved completely out of being the innovation or architecture role, completely into operations.
Day by day, yeah.
Yeah. And that's actually really cool. And that's a sentence I will borrow from a colleague of mine who said, well, we have this nice technology, let's do something useful with it. And that's interesting if you see all the sides of the story here.
It's an interesting point of view.
And just recently got back to the EBU, another opportunity, moving now into the realms of IT. And this is probably where we can kick off with the real panel today.
Yep.
Because back in the days, as a user, we had already the idea. Let's move into the software world, and this means, well, IT-based systems. And when we had this early proof of concept back in 2015, 2016, we thought about non-functional requirements, and that's the flexibility, the scalability, and the shareability of all the pieces of kit you have in your operations. Now, with shareability, we need to think a little bit about what's called, and I'll try to pronounce it correctly, the dematerialized facilities. Yes, the dematerialized world. That's a word brought to the community by Félix Poulin from CBC back in the days, and I had to train myself years and years to be able to pronounce it. Sorry, I'm not fluent in English, so this is why. Now, one thing we saw as evident back in the days was it's similar like the telephony system, right? The old telephony system, when you have the telephone, when it was invented, you had these ladies patching the cords, making sure you set up a connection. And actually 2110 is a little bit the same thing. It's just the data plane. So we thought, well, we need something else. We need to have a control plane. And from the EBU community, the user community on, we were advocating, let's have something from the start here. And in hindsight, we probably thought, well, maybe it's normal that we didn't add it on. at the start, because it was a huge effort already to bring 2110 to market. But Pedro, this is probably where you want to chip in with AMWA and what happened around that period.
Yeah, you're right. It was too much to write at once, right? To address the data plane and the control plane. And yeah, ST2110, just like many other protocols, it focuses on transferring data. And of course, we need to control that. Otherwise, it's just like a train carrying stuff, but you don't really take it to the right direction. And yeah, luckily, the AMWA had already started by then these efforts to start defining specifications around the control plane. And this is what NMOS does. NMOS's fundamental goal is to be a control layer on top of a data layer. And not only ST2110, again, NMOS had already started before even we had an actual set of specifications for ST2110. And there's a few things quite interesting and in line with what you were saying about this move to software related to NMOS. And that's mostly the big idea behind NMOS is to use existing internet technology. So instead of reinventing the wheel, if you look at the internet, if anything scales, is secure, and there's a lot of tools from, that's definitely the internet, right? So why not just reuse that technology instead of doing what our industry had done for ages, which is to reinvent the wheel? And then most precise of that. Take technology that was used on the internet, leverage that, and by doing that, it prepared the path towards the dematerialization, towards moving to the cloud, public clouds, private clouds, whatever, but more importantly, moving to software-based, right? And the core technologies around NMOS are HTTP, REST. So we use REST to talk from a client to a server, where a server is a device. We use things like WebSocket for notifications, etc., etc. So not reinventing the wheel, right?
Yeah, that was just going to be my question, right? Because back in the days, well, reinventing the wheel, that's something that we'd love to do. But now we're just reusing whatever the IT industry is using, I would guess.
That's the whole point, absolutely.
Yeah.
Just
Okay.
take the tools that were developed by a much larger industry and reuse it as much as possible.
Yeah. So I was just saying a little bit earlier that I was driving back from Paris to Geneva. And as we speak, there's a big tech conference going on that's called Viva Tech. There's also the NVIDIA GTC is there, really spectacular. And everybody's talking about sovereignty these days, about sovereign clouds, etc. So I guess this is an important topic for broadcasters as well, this cloud topic, and moving some of their capabilities into a cloud. So what would be the reasons? Why would we tie NMOS to 2110?
Well, firstly, because 2110 needs a control layer, right? And yeah,
Sorry,
I think
that was kicking in the open door here. Sorry.
Yeah, but the community or the industry could have chosen other way of doing that, right? And I think the reason NMOS took the lead and was adopted by a large number of manufacturers was maybe twofold. So one of them is the fact that it's open and free, right? It's an open specification. You just go to GitHub and to amwa.tv, and there's everything up there. It's free, as in free speech and free beer, right? So you can just use that. You don't need to pay royalties for there.
Both of them are important, by the way.
Yeah,
speech and
or gin and tonic. No, seriously. And the fact that it's open and that we define a series of interfaces between a controller and the devices, that's fundamental to simplify the development of broadcast control systems, right? Me as a software engineer, back in the day, I had to implement a number of different controllers for different devices, from robotic type devices to whatever. And the protocols were always different. And the big thing about NMOS is that the broadcast control system can reuse the code. So it talks to the same API. So it's the same thing talking to one device from one manufacturer and another device from another manufacturer. And please.
Well, you touch upon a very interesting topic because, and now the CAP as a user, we spend a lot of money in integrations and it doesn't add value to our value chain, so to speak. So if we can simplify this by using open specifications that everybody just can use, this would be really, really awesome. It would spare a lot of headaches, I would say.
Yes, and we'll turn back to this when by the end we talk about testing. That's another fundamental thing, right? And both of us, we were very much involved in JTNM testing events, and we saw the simplicity it was, in a way, to test different devices because they were all talking NMOS, and that's a huge thing, right? And I said this was twofold. So this is one aspect. The other aspect is that NMOS covers the most fundamental traits of a device. So firstly, discoverability, right? You want to very easily discover new devices on your network. So to have a kind of a plug and play environment where you buy a device, you rack it up, you connect it to power and network, and that's it, right? And the first specifications that NMOS published were around discoverability, right? And the other aspect, which is the main message now on AMWA, which is connect and control, right? You want to connect devices to one another and you want to control them. And control means a lot of things and completely different things for different people. There you go. That's the message, right? NMOS connect and NMOS control. So NMOS covers this gamut of functionality, which are absolutely fundamental to control, to the control plane.
Yeah. So let me go back here. Okay. So another question regularly asked, by the way, it's why is NMOS? Well, it's difficult, and why is it so difficult? But actually, well, I'll make a very short sentence here. Well, NMOS is a suite of documents. It's a suite of documents, just like 2110 is a suite of documents. That would be the punchline here. Pedro, how do you look at it?
Well, firstly, why is NMOS a suite of documents? And well, it's actually to make it simpler. It may look more complex at first, but the fact that NMOS is split across several independent documents or loosely dependent documents actually helps understanding NMOS and helps implementing it, right? So the idea is that, as I said, we started with the fundamental aspect, discoverability. So there's NMOS interface specification number 4, ISO4, as we call it, that defines how a device registers or exposes itself to the network so that it can be discovered, right? So this is one aspect and can be used on its own. And then you want to connect devices. So we have a different specification that allows you to connect devices to one another, ISO5. By the way, ISO5 is mostly used to connect ST2110 compliant devices, but it can actually be used to connect other kinds of, or devices that implement other kinds of transports. And there's been significant work around that.
Yeah, I even heard that there's some implementation floating around in the world that uses NMOS and NDI.
Yes, there's work around that. There's work around different transports. So if you look up there, there's NDI, there's SRT, there's MPEG transport stream over RTP or UDP. There's importantly RIST. There's all sorts of different transports that we can use ISO5 to connect. And by the way, not only media transport, but also event transport. There's yet another specification called ISO7, event and tally, which allows a device to produce events and other devices to consume those events. And again, you can use ISO5 to connect those events, consumers and producers, right? And then there's other aspects to this control plane, like monitoring, BCP00802, which allows you to monitor devices, right? So again, back to your original point, the fact that it's divided into bite-sized chunks actually makes NMOS easier to understand and easier to implement. And importantly, it's based on internet technology, right? So you can use tools that are, familiar to any software engineer out there, and you can implement NMOS.
So actually, the summary, if I could summarize this, Pedro, is like it's the elephant, and you just need to slice it in small enough pieces, and everybody can eat the elephant, right?
Yeah, the elephant is the whole problem of controlling a system, a facility, right? Which I think everyone will agree it's quite a complex challenge, and by defining it becomes easier.
It's far more complex than just a telephony system, because that's only picking up the horn or the thing and then just dialing, and then there's a signal that you start, you hook up the phone, you stop, that's it. But if you think about a broadcast facility, people like to push buttons. There are rotaries, there's volumes, there's red lights, all that sort of things.
And there's monitoring, right? Monitoring is also extremely important. And then there's configuration, the fact that you want to be able to take a snapshot of a device's configuration so you can reset it to that configuration, or if you want to replace a device by a spare and you want to apply the same configuration to that spare, that's something that either NMOS already supports or work is underway to support, and is fundamental for the correct operation of a facility.
So back in the days, now people will think, oh, he's there with his pyramid. Back in the days, we created this thing called the pyramid, and it's actually something like an ISO layered model, but upside down, because the basic layer is on the top, and the more you go down, the serious we get. And actually, where there's still a little bit of red, well, not a little bit, where there's red, those are the two layers like security, but that's an eternal goal, right? You want to be secure, but this is just software land. So each time there's new flaws that need to be protected against. So it never will be purely green. That's probably a thing that we should take in mind. But just above this, when you operate a facility, actually, when you're in the IT realm, you can monitor things and know things up front before they break totally. And I thought there was some work in AMWA being done on this right now.
Yes, there's definitely work on that area. Actually, I think we've gotten to a point where discovery and registration and connection are taken for granted. It just works, and there's plenty of devices out there that support those specifications with I won't say perfect, but extremely good interoperability. And now the challenge is probably mostly around the aspect of controlling, as in operational control, configuration, and very importantly, monitoring. And all of these three different aspects, they fall into something that's been done in AMWA, which is defining a model for that. And there's something called MS-5, which is a specification that gives you a way of modeling things, so that if you have this, it's kind of an object model or a way of you introspecting the device, right? So you connect to the device and can learn about it, can learn about the interfaces it exposes, the control points it has, and all that. So, for example, if you have say a microphone preamp and you want to set the gain, you can use a protocol to connect to that device and look for the control points it has, and it will say, okay, I have a gain here, and by the way, my range is from 0 to or minus 30 dB to 30 dB, and then you can set those values, right? And with that model in place, then we can reify that model into a protocol, and we have IS-12, which specifies how you actually talk, how the bytes travel in the wire, right? And on top of that, we have another one called IS-14, which is a slightly different take on that for a slightly different use case. And with all that, we can start building concrete implementations of control. One of them is monitoring. So we have BCP00802, which is a way for you to talk to the device and see the status. And you may say, well, that's really simple. Yes, it is. But you just grow from there. And it is apparently simple because if you talk to 20 different manufacturers, usually you have 20 different ways of doing that, right? And the fact that you can do it the same way with any manufacturer is a huge advantage.
Yeah, one of the things I noticed back in the days is like, well, first of all, when you start to installing equipment like the tested event, everybody looks, are the lights blinking at the back of the frame? Can I ping it? But then another question would be, do I have blackburst, or in the 2110 world, do I have PTP? Is the device locked?
Yeah.
This would be so nice if we have a visual on this, and if the monitoring part helps in looking if the redundant NIC does work and that sort of things. This is really lovely. I saw a demo, by the way, at NAB with traffic lights. There's even somewhere on YouTube a short interview with Brad Gilmer from the AMWA talking about this. It's really interesting, and you get a visual how it works. And I think a lot of operational people would love to have something like this. So we probably need to chuck on a little bit, and we should be careful because we're running into a topic that we dearly love, and it's moving into the IT world. And moving into software, well, Pedro, you've been writing software for 20 plus years. You have experience.
I wish 40, and professionally almost 30 anyway.
Oh, but you're growing younger each year. So, but perhaps we need to talk about software and the software world, because there's a little bit of a different world than the boxes that we used to have, right? And I have a slide supporting this.
You do. Yeah. We all know how software works, right? And how often, if I take this, my phone, my smartphone, we all know how often software gets updated, right? And it definitely is this infinite loop. So you write software, or we write software, we build it, we deploy it, people use them, people use the software, and then they start saying, well, this button should be red and not blue, and maybe you could add this feature and that feature, and maybe could have a slight different take on this. Or we come up with ideas and we publish new software and all that, and it just goes on. It just goes on. We're no longer in a state where you take some kit, rack it up, and it would sit there for 10 or 15 years. That's no longer the case, right? So we need to learn how to do that. And code needs to be maintained. Even if you don't want to change it, it needs to be maintained. Interestingly, we were talking about this earlier this week. There's this new European Union's Cyber Resilience Act, which will change significantly the rules on how you publish software, and the responsibility manufacturers will have on making sure that the devices and the software they provide is secure. So there's no way around this, right? We will continue to update software even if we don't want. So we need to change the way we operate devices / software. And the burden will often move towards the end users, the broadcasters, and making sure that there's mechanisms in place so that you can do the software upgrades in a safe way. And the reason I'm saying that is, if you have devices from different manufacturers that talk different protocols, your broadcast control system will have a hard time making sure everything is in sync, right? So the fact that NMOS provides APIs that are public, it makes it much simpler to maintain that's the software and deal with the change, so that you don't need to adapt to changes in like 30 different manufacturers. That's absolutely fundamental.
Yeah. Now the great part on this infinite loop, well, of course, there's the word monitor. We already talked about monitoring. Might be a different set of monitoring, but there's in the big blue or the deep blue part of the infinite loop, the word test. Yes, and we already talked about the JTNM tested, or we just referenced it. But I'm very, very happy that there's also something like a test suite available. Can you dive in this a little bit more, Pedro?
Yes, of course. As I was saying, it's inevitable that systems integrators and actual broadcasters will have a greater responsibility in doing their own testing. So making sure that the different products they own, they correctly interact. And therefore, we would certainly advise people to have their own test lab where they can test new releases of software, test new devices. And in terms of testing NMOS, there's an excellent facility provided by AMWA, which is NMOS testing, the NMOS test bench, which is, again, publicly available. It's relatively straightforward to use. You just go there, it's a GitHub repository, you clone it, and then you start running tests. So if you have a new piece of equipment you want to test, you just run tests, right? And of course, we at AMWA strive to make sure that whenever we publish a specification, there's a series of test cases that cover that specification. So if a manufacturer implements the set specification, they will be able to run the test suite against their implementation to make sure that things are working correctly. But not only that, end users will be able to do the same, right? So as you upgrade software, you can rerun the tests and make sure that things are still up to date in terms of compliance. Of course, the NMOS tests, they validate the API, right? If you tell a video server to start playing, it doesn't guarantee that the actual picture will look good, right? But in terms of control, they will certainly be invaluable in that respect.
Yeah, it tests the control plane, of course. And if you want to have the full picture, no pun intended, then you need to have the control plane and the data plane, of course. So looking a little bit further, how can people just work with this? Are there things available? Yes, there are things available. There's the AMWA.tv website. You can join, of course, as a vendor, but also as a user. You just click on this nice join button and you'll find the way, and you probably end up with a lovely lady called Cindy that will respond to you. Now, we also said, well, that there are a lot of tools available out there that you can just grab and use. The Easy NMOS container, the NMOS CPP from Sony, as Pedro mentioned, the sender receiver framework, the testing framework. And can you enlighten me a little bit about the sender receiver framework?
Absolutely. So the idea there was to make it easy for anyone just to, have an NMOS system which actually sends video and audio between different entities in like 20 minutes or even not even that, right? So you just go to GitHub, clone this repository, and really quickly you'll have senders and receivers that you can play with. You can actually listen to the audio, see the video, and see NMOS in action.
That's really cool. I'm just a little bit mindful about the time, and probably we have maybe a minute left to look at a few questions. So let's quickly see if I can. Oh, there's a very nice one. Is there any limitations of areas of ongoing development with NMOS when applied to the full scope of the DMF?
Oh my, we need another 30 minutes, I guess.
Yeah, but I love the question. Of course, the DMF, that's a big puzzle. And one of the pieces of the puzzle is, it's again the data plane, by the way. That's what's called the media exchange layer. But of course, there needs to be control with it. So
Yes.
if I have something to say in this, I would say a lot of our members from the EBU have invested in 2110 systems, also in knowledge and know-how about NMOS, and are using NMOS. So if we suddenly can change the data plane with, or add the data plane with a little bit of our DMF, then of course we don't want another control plane. So I'm a huge fan of just continuing to use NMOS in this field as well. Maybe there need to be some adaptations, some additions. Let's see. Let's see what the future brings. But this is actually the idea to continue using this as well.
And NMOS will certainly follow suit there. There's already work underway to get prepared for that. There's another interesting question, which is the difference between NMOS, device enumeration and automation, and orchestration, right? And very quickly, I will say that before you orchestrate, that is, you coordinate actions across different devices, you need to discover them, right? And NMOS ISO4 is the way for you to discover them, right? Once you discover them, then you need to orchestrate. And in order to orchestrate, then you probably want to use protocols like ISO5 to set up connections, IS12 to act on the device's configuration and parameters, etc., etc.
It's hard to pick questions, but I just want to reinforce one thing, and it's not a question, it's a exclamation mark. There is an end users or / customers group, and you can sign up, you can look in the chat, and it's on Slack. So if you want to join that users group, ask any question you have. I've seen it active. I've seen the user asking a question and you get direct response from the guys who are actually coding the thing. So that's really, really helpful. That's what I call a very short form of working. You get direct access to the guys who are working on it. Any other, Pedro, do you see any other question? I see a lot of text now passing by.
No, not really. And I think it's probably time to wrap up.
Oh,
but
yeah,
anyway,
we're already 2 minutes past.
We are, but
anyway, running late.
If there's any questions, please get in touch with Cindy. Please get in touch with me and Willem. I believe I can also say, do get in touch with you, because you're usually quite keen on answering questions on the community, asked by the community, and I am definitely looking forward to it. So any feedback, please do get in touch with us.
Yeah, excellent. So thank you for being with us.
Thank you for inviting me. Have a great day. Thank you, everyone.